Welcome back, everyone. This is episode number 4 of our CSCA Physics Preparation Series. And if you are new here, we have already covered mechanics, electromagnetics, and thermodynamics in our previous episode. All links are in the description. Today, we are moving to a very beautiful topic, and that is optics. This topic is all about light, how it travels, how it bends, how it reflects, and it is very scoring in the CSCA exam if you understand it properly. So, as always, quick syllabus overview first and then straight into my handwritten notes. So, let's go. Today we will cover topic optics, and within optics we will cover geometric optics, and within geometric optics we will cover the subtopic law of reflection and refraction, and the next subtopic is physical optics, and within physical optics we will study interference and diffraction. So this is the handwritten notes of me, which I prepare when I have start preparation for the CSCA examination. So today we will cover geometric optics, and geometric optics, the important things that we will study: the law of reflection. So the law of reflection say that the incident ray, reflected ray, and normal at the point of incident lie in the same plane. They say that the incident ray, the ray which are going to interact with another medium, are called incident ray. This is the incident ray. Okay, this is the incident ray. Now and reflected ray, this is the reflected which reflect from the surface, from the hot surface, is called reflected ray. And the normal is the line which is drawn when from the point where incident ray and reflected ray are join or reflect. So it is the line which is a 90 which make 90 angle to the surface where incident ray and reflected ray are here drawn. So the law of reflection say that the incident ray, reflected ray, and normal at the point of incidence, it is the point of incidence, lie in the same plane, will be in the same plane, mean that if it is air, so it will be in the air; if it is water, so it will be in the water. Now the next uh, postulate of this last, that angle of incidence is equal to angle of reflection. Here see that this is the angle of incident, and this is the angle of reflection, and the postulates say that the angle of incidence must be equal to the angle of refraction, and the angle of incidence is represented by I, and the angle of reflection is represented by R. Okay, so this is the law of reflection. Now here the one of the important thing is that mirror formula. What is the mirror formula? It is also called spherical formula. So the mirror formula is that 1 over f is equal to 1 over v plus 1 over u. Okay, so this is the mirror formula. And the next thing which you must know that what is magnification, magnification of mirror. Okay, so to find the magnification of mirror, we have formula that m is equal to hi by h naught, and it is also equal to minus v by u. What is focal length? Focal length relationship. So the next important topic is the focal length relationship, which is equal to f is equal, f represent focal length. Okay, and it is equal to r by 2. Now we will cover the next subtopic, which is the physical optics, and it is interference and diffraction. Okay, so and the law of so the law of refraction. Sorry. This is the continuation of the first subtopic. Okay, geometric optics. This topic is also from the geometric optics, which is a law of refraction. What is the law of refraction? It is also called Snell law. So law of refraction say that incident ray, refracted ray, and normal lie in the same plane. Same place. This postulate is same as of the law of reflection. Okay, so and the next they say that for two given media, sin I divided by sine r is equal to constant, which is mu. Okay, what is a refractive index? Sorry, this is the refractive index. Okay, and what is the refractive index? The refractive index is the c by v. This is the formula which you must memorize and take practice of it. What is critical angle? Critical angle is equal to sin c is equal to 1 over refractive index. Total internal reflection condition, this is also important that you must know what is the total internal reflection condition. So mean that when will be the light totally internally reflect. Okay, so when they follow these two conditions, it will be totally internal reflect. It will show the phenomena of total internal reflection. Okay, so the first one is that a ray must travel from denser to rare medium. The first one lies that say that the ray must travel from denser to rare medium. Denser medium, let's take an example which will clear all this thing. There is a water, okay, and that is one medium, and the next is air. It is the second medium. So to to verify the total internal reflection condition, the ray must travel from denser. Water is denser medium. Okay, the water have high density while the air is low density. So according to total internal reflection condition, they said that the ray must travel from denser medium, okay, denser medium to rare medium, then they will be totally internally reflected. Okay, and the next they say that angle of incidence, okay, angle, this is the angle of incidence, must greater than critical angle. Here it is the angle which medium make with the normal is called critical angle. Okay, so here the next condition is that angle of incidence must be greater than angle of then a critical angle. Okay, now let's go to the next subtopic, which is physical optics. Okay, and here this is the next subtopic, physical optics. And physical optics we will study interference and diffraction. Okay, so what is interference condition? What is the condition of interference? It is important. So a condition of interference is that they must have coherent source and same frequency and constant phase of difference. What is a path difference? You must know a path difference. And what is a bright fringe, which is maxima? So we will represent it and delta, and it is equal to n over lambda, and lambda is equal to 2n plus 1 over lambda by 2. What is Young double slit experiment? It is also represented by YDSE. Okay, and what is French weight? French weight is magnetic field, and to lambda d over small d. D is the distance between screen and slits, and D is the distance between slits. Okay, small d is the distance between slits. So you must know about all these things. I am actually showing that what you should learn within the physical optics. Not I am going to discuss it discuss its detail and all other things. I am only showing you that you must cover this subtopic and memorize these formulas. Okay, this is also a formula sheet for you. And if you want detailed notes, then comment me. I will make a detailed notes for you, and I will explain it this all this topic very clearly and in a good way. Okay, now the next subtopic is diffraction. What is diffraction? You must know, mean that you know the detail of diffraction. Okay, I am not going to discuss it with you in this short lectures. So single slit diffraction condition, which is minima, it is called minima, and what this single slit diffraction condition is that a sine theta is equal to n lambda. Width of central maxima is equal to 2 lambda d over A. This is all the formulas which you must know. What is the key difference? This is very important MCQs point. What is the key difference between the interference and diffraction? So interference due to superposition of waves from two sources. Interference occur when there is the superposition of waves from two sources. Okay, diffraction due to the bending applied at each of slit. A diffraction occur when there is a bending applied at each of slit. So this is all for today, and that is a ref on uptakes. I hope everything was clear and my notes made this topic easy for you. We are now 4 episode in mechanics, electromagnetic, thermodynamics, and now optics. You are doing great if you are following along. Episode number 5 is coming very soon. Make sure you are subscribed so you don't miss it. Write your question in the comments, I will answer them. See you in the next video.